Hi everybody, welcome back. This is going to be your first Cornell Notes video in AP Chemistry, so congratulations for being here. What we're going to do is we are going to learn some tricks and remember some skills we already have so that we can do math mentally. Okay, so we need to be able to do a lot of math without a calculator because the first half of your AP exam has to be completed without a calculator. Now, a couple of things to help you not freak out about that. One, you've been doing math for a long time, and for a long time you haven't been able to use the calculator, so a lot of this is going to be stuff that you've done before. Another thing is that that part of the test is going to be multiple choice, so I don't want you to freak out about that. That portion of the test that you don't use a calculator for, that's going to be multiple choice. So you can at least use these tips, tricks, and skills to kind of help you narrow down your answer choices and get a better score on your AP exam. Okay, it'll also help you do it faster because you're not having to, type a bunch of stuff in a calculator. Okay, all right. So the essential question: what skills can be used to perform mental math? Okay, so there's the essential question. We're just going to be talking about that. All right, so first up, you can't do math without order of operations. That's just the way it is. So listen, I know you guys know PEMDAS, okay? Please, that's parentheses. Anything in parentheses, you got to do that up front. Excuse, that's exponents. We have a lot of them, okay? The M for my is multiplication. Dear, that's division. The A in aunt stands for addition. And then Sally, substitution. Okay, so remember the order of operations. You have to do anything in parentheses first, then the exponents, then multiplication, then division, then addition, and then subtraction. Okay, so let's talk about multiplication. Okay, so first off, multiplication is what we call commutative. We can commute, we can move around. Okay, so if I have ABC, I can rearrange that and I can call it CAB. And you know what? Once I multiply whatever values are assigned to those three variables, I would end up with the same answer. So that's fine. Okay, it's associative. Okay, so if I have A, then I can go ahead and if I needed to, I could pull C out. I could move things around again. Okay, we could do that if we needed to. It is distributive. Okay, and this is a really big one. So let's say that I had A and then some function. I'm multiplying A times this function in parentheses right here. Okay, so what I could do is I could distribute, and I know you guys have been in math before, so you know what that means. And this can become A times B plus A times C. Okay, so I would just distribute A to both of those. And once I do that, maybe that function becomes a little bit easier for me to do in my head. So that's why that's an important thing to keep in mind, okay? All right, so listen, we have this example right here, but I'm actually gonna skip that one. I'm gonna talk about a trick a little bit later that'll make it a little easier, okay? We're gonna look at this one right here. So let's say that on the test, for whatever reason, I have to multiply 97 by 40. Okay, not thinking in my head, I'm thinking, okay, well, I could, do it the long way and do multiplication out to the side. Or I could think. What number is kind of close to 97 that's easier to multiply? Well, I already know what that is. Close to 97 is 100. Okay, so let's do 100 times 40. Now that's easy. You just put a couple of zeros on there and that's going to be 4,000, right? Okay, but that's not close enough. I actually just want 97 times 40. Well, what's the difference between 97 and 100? That's going to be 3. Now, 3 times 40 is easy. 3 times 4 is 12. You tack a 0 on there, and that's 120. So I need to take 4,000 and take away 120, and what I'm going to be left with is 3,880, and that's going to be the answer to this problem. Okay, so sometimes moving things around makes it a little bit easier, and we're going to be talking more about those tricks in a minute. Okay, all right, so let's talk about division. Okay, now with division, you can't really move things around as much. Okay, it is not commutative or associative. Okay, the order matters. You can't simply, if you have 100 divided by 10, you can't move it around and say 10 divided by 40 and have it be the same thing. That doesn't work, okay? It is, however, distributive. Okay, and here's what I mean by that. I've got 176 divided by 8, so I'm already thinking this is going to be a tough problem. And here's really how I think about this. I know that 8 times 10 is 80, right? Okay, so 80 divided by 8 is going to be 10. So I just kind of move that around a little bit. And you know what? I got another 80 in there, I think. Okay, now if I take those two things, I've got 160 there, right? Okay, well, what's the difference between 160 and 176? It's 16. And 16 divided by 8 is 2. So if I have 8 10 times, I get 80, right? If I have 8 10 times again, I get another 80, so that's 160 altogether. And then if I have 8 2 more times, that gives me 16, and that gives me 176. So I need 8, a total of 10, 22 times. So 176 divided by 8 is 22. Okay, 8's going to go in there, a grand total of 22 times. Okay. All right, so listen, so there are some rules we need to remember about exponents, okay? Now this first one you're gonna see a lot, okay? A lot of times we have either a unit or some value on the bottom of a proportion. So listen, if we get that, then that's gonna be x to the power of negative exponent. So that's the same thing. And I'm gonna go ahead and tell you that one of the biggest examples you're gonna see is molar mass. Molar mass is given in units of grams per mole. Do you see mole on the bottom of that proportion? Well, sometimes that unit is written grams times moles to the power of -1. Okay, so that exponent just comes out and becomes a negative whenever you have it on the bottom of a proportion like that. Okay, all right, next up with exponents, listen, anything held to the power of 0, that's going to be a 1. Okay, so just remember that one. And again, we will be using that quite a bit this year. Okay, now if I have two values, they're the same thing, held to exponents, what I can do is I can just take x and hold it to the power of those exponents added together. Okay, and if I have x to the power of a and x to the power of b, and I'm dividing right there, then I can just do the opposite thing, right? Remember that on the bottom of that proportion, it becomes a negative exponent, so watch. So this becomes x to the power of a minus b, right? B is negative because it was on the bottom. And then if I'm distributing here a little bit, if I have x to the power of a and then I have to hold it to another power, I can simply take x and then multiply those exponents. Okay, so those are just some things to keep in mind whenever you're working with exponents. Now another thing that you're going to see quite a bit in AP Chemistry is the logarithm. And generally we only do logarithms with base 10. So really what I want you guys to remember is that logarithm and base 10 are basically the opposite of each other. In fact, if I have base 10 to the power of some exponent and then I log it, guess what? I'm going to get a, because the base 10 and the logarithm, they cancel each other out because they're opposites. Okay, it's like adding 5 and subtracting 5. You end up with 0, right? It cancels out. So when you have base 10 and logarithm, they cancel each other out. If you ever have a logarithm and you need to go back algebraically, then you do base 10. Okay, same thing with natural log and e. Okay, so if I have e to the power of some exponent and I natural log it, guess what? I just get that number. Okay. Now let's say I need to log something and I have two values multiplied by each other. This happens a lot too in chemistry. So what we can do to make this a little simpler for ourselves, and generally for these problems with the logarithm, you would get a calculator, okay? But just so you know what to do with that, you could do log of A, and then you could add log of B. And so that makes it just a little bit simpler for you, okay? And you know what? If we're dividing, then it's the opposite thing, right? You have log of A minus log of B, right? And since B is on the bottom of that proportion, that negative had to come out somewhere, right? And then if I have this right here, which you probably are not going to see very often, but just realize that you can, if you need to move that around, you can put B up front and then log A. And then that might make it a little bit simpler to do that, okay? Another thing we're going to deal with quite a bit is the metric system, okay? So right here, you'll notice that I have some letters, okay? And those are actually, this is a little acronym, okay? The little U in the middle stands for unit. So you could drop any unit in here that you need to. It could be liters or meters or grams, anything can go in there, right? This is kilo. This is hecto. This is deca, okay? And then once we get smaller, deci, centi, and milli. Okay, so the way that this works is basically with the metric system, all we're doing is moving a decimal, okay? And the reason for that is that, let's use liters as an example, right? Let's say I have a liter. Well, a decaliter would be equal to 10 liters, okay? A hectoliter would be equal to 100, and a kiloliter would be 1,000 liters, okay? And then going backwards, a tenth of a liter would be a deciliter, 1/100th of a liter would be a centiliter, and then 1/1000th of a liter would be a milliliter, okay? And so actually this helps out a lot because let's say that I needed, let's say that I had 5.0 liters. Okay, this is my example. I have 5.0 liters and I need to convert that to kiloliters for whatever reason. Well, if you look at this, I have to move this direction 1, 2, 3 times in order to get from my base unit that I have to kiloliters, which I want, right? So I need to move 1, 2, 3 times to the left. Well, guess what? My decimal is going to do the same thing. 1, 2, 3. And then those empty gaps get filled in with zeros. So if I had to convert 5 liters to kiloliters, it would be 0.005 kiloliters, which is a really weird unit we probably aren't going to use, right? It would be more likely that we would turn that into milliliters, right? And if we were going to take my 5.0 liters, again, and turn that into milliliters, well, I need to move to the right 1, 2, 3 times. So that decimal is going to go 1, 2, 3 spaces to the right, and this becomes 5,000 milliliters. Okay, so this is just kind of a simple way for you guys to very quickly do metric conversions. You really should, if you're converting within the metric system, you should just be moving the decimal. Okay? All right. All right, so listen. What are some tricks that we can use kind of a little bit to help us out with this? Okay, well, the big one is to round, because let's face it, if it's a multiple choice test, rounding can get you close enough to one of the answers that's a choice, right? So if I have Avogadro's number multiplied by 4.1, okay, what is that really close to? Well, that's really close to 6.026, right, times 10 to the 23rd. You got to keep that part. You can't round and take an exponent off. It doesn't work that way, okay? And you can multiply that by, well, 4.1 is really close to 4, isn't it? So now I've got 6 times 4. What is 6 times 4? It's 24. Times 10 to the 23rd. Like I said, that part didn't drop off at all, okay? Now, that's not correct scientific notation. The rule for scientific notation is that one digit should be before the decimal number, okay? 24 is 2 digits. So we actually need to move that over one more time, so that becomes 2.4. And then since I moved it, since it was a large number, and I moved it to make that number smaller, I'm going to make up for that in the exponent. I'm going to add 1 to the exponent. Okay, so when you're taking a large number and you're moving the decimal to make it smaller, to make up for that fact, you got to make the exponent bigger. Okay. In fact, the next thing is to just go ahead and start putting stuff in scientific notation, especially decimal numbers, in order to make that process a little bit easier. Okay, so when you have a bunch of decimal numbers, go ahead and put those values in scientific notation. And then that way you can deal with the whole numbers and the decimals separately, right? Because looking at this is kind of an intimidating problem. But if I go ahead and I just kind of move it around and turn these values into scientific notation, if I move this, and I'm actually making it larger now, right? 0.06 is a very small number, and I'm going to move that decimal to make it larger. So that's going to be 6 times 10 to the power of -2. Okay, since I made that number artificially larger, I got to make my exponent smaller, so that became negative. And then that's going to be divided by 0.002, so I need to move that decimal over 1, 2, 3 spots. And since I was taking a very small number and making it artificially larger, I've got to make up for that by making my exponent smaller. Okay, so it becomes more negative. So that's 2 times 10 to the -3rd. And then I'm multiplying that by 15, which, you know, that's easy, it's 15. But, you know, why don't I go ahead and just move it? So if I move that decimal and put it right there in between those two values, that's going to be 1.5 times 10 to the 1st power, because I had to make that number smaller, so my exponent got bigger by that same number of places. I only moved it one place, so it's 1.5 times 10 to the 1st power. Okay? All right. So what do I do next? Well, if I look on the bottom, I have multiplication first. PEMDAS, right? I have to multiply before I can divide. And it actually makes it simpler. 2 times 1.5 is 3. And if I have -3 and +1, I add those together. Since I'm multiplying those two exponents, I just add those together. -3 plus 1 becomes -2. So just watch whenever you're doing the math on that. And then on top, I have 6 times 10 to the -2nd power. Okay, so remember, when you have the same thing, top and bottom, it cancels out. 6 divided by 3, guess what? That's 2. And that's it, we're done. Okay, that turned out to be a very simple problem once we turned those values into scientific notation and then used PEMDAS correctly. Okay? All right. Another thing we can do is remember that when we have multiplication, it's commutative, so we can kind of move things around. And in doing so, we can multiply and divide in simplifying steps. Okay, so for example, I have this problem right here. I have 81 times 42 divided by 6 times 9. Well, here's the thing. I see 81 and I see 9. Why don't I put them on top of each other? 81 over 9, right? And then I have 42 and 6 left over. So 42, 6. Now I've got the numbers top and bottom. I've got the division in there. I just need to multiply to get some multiplication. So 81 divided by 9, well, that's 9. Okay. 42 divided by 6, that's 7. So now this becomes kind of a simple multiplication problem. It's 9 times 7, and there's actually a trick for 9s.
If I could please have the AP secretary.
I can't believe that this is going to be in my video.
My conference room for just a minute. AP secretaries, please meet in my
I'm not making this video over.
Thank you, Tight Pride.
And I don't know how to edit, so you're just going to have to hear Motley. Okay, all right, here we go. There's a trick to multiplying 9s. If you don't know the trick for multiplying 9s, listen, you got 10 fingers, right? Starting with the pinky over here on the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Okay, well, I'm doing 9 times 7, so 1, 2, 3, 4, 5, 6, 7. I'm going to bend that 7th finger back. Check it out. I've got 6 fingers over here on this side, and I've got 3 fingers over here on this side, and that's going to be 7 times 9. It's 63. That's the answer. I learned that trick when I was in like 4th grade. You're welcome. Okay. All right, last one. Oh, you know what? And that actually brings me back to the front. I wanted to go over that before I did this first example here on the front, because, I mean, if you look at it, How could we rearrange that? Obviously, we can't, flip the top and the bottom because that doesn't work out, but we can rearrange the top, and we can do 21 times 4 over 7 times 2, right? Okay, now this is math that's pretty easy. 21 divided by 7, that's 3. And 4 divided by 2, that's 2. So 3 times 2, it's 6, y'all. That's easy, okay? So it takes these complicated problems and it makes it a whole lot easier. Okay. All right, next one. Turn division into multiplication, decimals into fractions, and solve it as convenient. So I know that sounds really confusing, but listen, okay. 542 divided by 0.33. Sounds terrible, right? Here's this part right here. Turn decimals into fractions. Well, 0.33 is about a third, isn't it? So really I have 542 divided by 1 over 3. Now, if you're dividing by a third, that's basically the same as multiplying by 3. That's what we're talking about, division into multiplication, right? If you're dividing by a fraction, it's the same as multiplying by that right there. So 542 times 3. Okay, if you don't remember this paper math right here, 3 times 2 is 6. 3 times 4 is 12. So I'm going to put that 2 there and hang that 1 up on the next place. 3 times 5 is 15, plus 1 is 16. So the answer to this is 1626. Okay? All right. And then the very last thing is to break multiplication into simpler multiplication and addition problems. So here we have a percentage problem, right? I need 15% of 36. So listen, if y'all have never had to, calculate a tip before, and you really should tip your server, just throwing that out there, okay? You guys need to know how to do this. So first off, if I want 10% of anything, I just move the decimal over right there. So 10% is going to be equal to 3.6. Okay? But I don't need 10%, I need 15%. So 5 more is going to be half of that, okay? And so that's going to be 1.8. And so then I just add those two parts together and I end up with 5.4. Okay, so 15% of 36 is going to be 5.4. And I hope this is helpful. Tomorrow in class, we're going to be working on this more.